Completing the square is a method that can be used to solve quadratic equations. Factoring is usually better if it works, but it doesn't always work. Completing the square does always work. So, these are the 6 steps that we're going to use to do this. So with this problem right here, we're going to first of all get in the form ax squared plus bx equals c. So that means we need to move the 58 over to the other side because it's not our a or our b term. So that gives me n squared minus 8n equals negative 60. Notice I left a space there. I did that on purpose because we're going to fill that in a minute. Our next step is to make a equal 1. Whether you have common factors or not, a has to equal 1, which in this case it already does. So we can go on to the next step. Our next step is to add 1/2 b squared to each side. This right here is our b. So we need to take half of that, which is negative 4, and then we need to square it, which is 16. So we will add 16 here and add 16. Okay, and let's go ahead and add this negative 60 plus 16, which would give you negative 44. Now, we see on the left side we have a perfect square trinomial, which we're going to factor. And the square root of 16 is 4, which happens to be the same number we have over here. That's not coincidence. It works that way every time. And it equals negative 44. Now we're going to take the square root of each side. Remember, a square and a square root cancel, leaving me with n minus 4. And then 44 we need to simplify. So if we have 44, that would be 2 times 22, 2 times 11. So a pair of 2's come out. Because it's negative, we also need to pull an I out to take care of the negative. And then we have 11 that stays in. And then remember, the square root always has 2 possibilities, the positive or the negative. And then our last step is to write 2 equations and solve. So n minus 4 equals 2i radical 11. N minus 4 equals negative 2i radical 11. We add 4. So that gives me 4 plus 2i radical 11. Add 4 here. And that gives me 4 minus 2i radical 11. So that would be your 2 answers. Again, for this example, we'll get the ax squared and the bx on the left and c on the right. So right here, we're going to look at everything that needs to be moved. The plus 12 is a c, so it needs to be moved over here. The 10k squared is part of the a term, so it needs to be moved to the left. Notice I'm going to line it up with my like term over here. And then the minus 3k, that's part of the b, so it needs to move over here. So that will cancel these out, and the negative 6k squared plus 10k squared is 4k squared. Negative 19 plus 3 is minus 16. And then over here, I'm left with a negative 12. Notice again that I did leave a space there. Now my next step is to make a equal 1. Let me back up here and then put the k. There should be a k there. Now we're going to make a equal 1. So we divide everything by 4, because right now a equals 4. And that gives me k squared minus 4k equals negative 3. Notice again that I am leaving a space there so that we can do the next step and add. Our b is negative 4, so we need 1/2 times negative 4, which is negative 2, and then we need to square it, and we get 4. So we add 4 to each side. And negative 3 plus 4 equals 1. Now we factor our perfect square trinomial again. Remember, we're going to use that number. The square root of 4 is 2, and 2 doubled is negative 4 also. Then we will take the square root of each side. So k minus 2 equals plus or minus 1. Now we write our two equations. K minus 2 equals 1. K minus 2 equals negative 1. Add 2. K equals 3. Add 2. K equals 1. So 1 and 3 are your two answers. Now this is one that we probably could have factored, but completing the square always works too. Right, with this next example, our first step again is to get ax squared and bx on the left and c on the right. Right now we have this b term on the right. It needs to be moved to the left. There's no like term over here to line it up with. So that just gives me 9n squared minus 18n equals 16. Again, leaving a gap. Next step is to make a equal 1. A is 9, so we need to divide everything by 9. Again, whether it comes out even or not, we have to divide everything. So it gives me n squared minus 2n equals, and 16 over 9 cannot be reduced, so we'll just leave it 16 over 9. Now we go to add 1/2 b squared. So 1/2 times negative 2 squared, which gives you negative 1 squared, which is 1. So we will add 1. Now over here, instead of adding 1, I'm going to add 9 over 9. 9 over 9 still equals 1, but it gives me a common denominator with the other fraction, which is going to help us when we go to add. So now we have n squared minus 2n plus 1. Add our numerators and get 25 over 9. Now we factor the perfect square trinomial. N minus 1 squared equals 25 over 9. And we take the square root of each side. So n minus 1, and since they're both perfect squares, that would be 5 over 3, and then we need a plus or minus. Now for the last step, give us some more space here. Write two equations and solve. So n minus 1 equals 5 over 3. N minus 1 equals negative 5 over 3. So here I'm going to add 1 over here. Instead of 1, I'm going to add 3 over 3. Again, because it's a fraction, I'm going to get another fraction with the common denominator, and the denominator is 3. So 5 plus 3 is 8. So that gives me 8 over 3. Also going to add 1 over here and a 3 over 3 on this side. And then negative 5 plus 3 is negative 2 over 3. So 8 over 3 and negative 2 over 3. Once again, we want to start by getting ax squared plus bx on the left and c on the right. Right now, everything is on the left, so we need to move the c. So that gives me n squared plus 15n equals negative 68. Now we need to make a equal 1. Well, a already equals 1, so we can skip that step. Next step is to add 1/2 b squared to each side. So we're going to take 1/2 times b, which is 15, and square it. Now 15 is not even, so we'll have to leave it as a fraction. And then 15 squared is 225, and 2 squared is 4. So we'll add 225 over 4 to each side. Now when I go to add this over here, I need common denominators. And if I'm going to make this denominator 4, right now it's basically a 1. And 1 times 4 gives me 4, so I need to do 68 times 4 also, which is 272. And it's negative still, plus 225 over 4. Then, when I subtract those, it will give me negative 47 over 4. And we'll bring this down. Okay, now we need to factor the perfect square trinomial. Now you may remember in the other problems I showed you, when we take the square root, it's always this number. And the square root of 225 over 4, again, is 15 over 2. So it's n plus 15 over 2 squared equals negative 47 over 4. Then we go to take the square root of each side. So n plus 15 over 2 equals, there's a negative, so we're going to pull an I out. We don't know the square root of 47. We do know the square root of 4 is 2, and then we need our plus or minus. Okay, now we'll write our two equations. So n plus 15 over 2 equals I radical 47 over 2. N plus 15 over 2 equals negative I radical 47 over 2. Then we subtract 15 over 2. Now since these already have a common denominator, we're just going to put the numerators together over the one common denominator. So negative 15 plus I radical 47 over 2. And then over here, same thing, we subtract negative 15 over 2. And these also have common denominators. So negative 15 minus I radical 47. And then we'll put the whole thing over 2. So my answer would be 15 plus I radical 47 over 2 and negative 15 minus I radical 47 over 2.